Welcome to this video on analyzing energy consumption patterns. In this session, we'll discuss how to use data mining techniques to understand and model energy usage effectively. Here's what we'll cover in this video. First, we'll explore how linear regression can model energy consumption. Then, we'll look at multiple linear regression for making better predictions. We'll also discuss how to evaluate regression models by checking key assumptions. Finally, we'll see how to implement and refine these models using Python. Stick around for the summary at the end to recap everything. Energy consumption is highly seasonal, with heating driving high demand in winter and cooling causing peaks in summer. Natural gas is a key resource, especially for heating, and its seasonal demand impacts prices significantly. For homeowners, understanding energy usage can aid in decisions like whether to install solar panels. Linear regression is a useful tool for modeling natural gas usage as a function of temperature. There's a clear negative relationship. As temperatures rise, gas usage decreases. This approach allows us to predict gas consumption during different weather conditions effectively. The Python code shown here demonstrates how to implement a linear regression model using scikit-learn. It fits the model, makes predictions, and visualizes the relationship between temperature and gas usage. While we won't go over the exact lines of code, the process is straightforward and highlights the power of Python for data analysis. To ensure our regression model is reliable, we need to evaluate certain assumptions. These include checking linearity to ensure the relationship between variables is straight, verifying constant variance in residuals, and confirming that errors are normally distributed. Residual plots are helpful in diagnosing these issues and ensuring model accuracy. Sometimes a simple linear regression may not capture all the nuances in the data. That's where polynomial regression comes in. By including terms like squares of input variables, we can model non-linear relationships more effectively. For example, a quadratic term might better capture the pattern of gas usage as temperatures change. The Python example here shows how to implement polynomial regression by transforming the input data and fitting a more complex model. This allows us to capture nonlinear trends while still maintaining interpretability. To summarize, we explored how to model energy consumption using linear regression and extend these models with polynomial terms for nonlinear trends. Evaluating model assumptions ensures reliability, and Python offers powerful tools to implement and refine these approaches. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.